Okay, so in this problem, a little bit different than our previous ones, we just want the bar forces in a few selected elements. And to help you out, I've just squiggled a little red line here next to the elements that I'm interested in. Now with all of our problems, it's always a good idea to see if you can get elements by inspection, which means our zero force members. Can we get any of these from zero force? Do you see any case ones? The only two places I see where two elements are connected would be A and E, but they have loads applied, so no case ones. What about case two? Well, there's H, there's three elements, two collinear. Also at F and also at C. But H and F have loads applied. What about at C? Does not. So that means this is a case 2. So which element is 0? CG. So our zero force members, using what we defined in the notes as case 2, should give us that the force in CG is 0. Everybody see that? Now, a lot of students are concerned because they like to look at the other end of the element and look at G and say, well, how do you know that's going to be 0? It doesn't look like it's going to be 0 at G. Well, it doesn't matter. You need to focus on just C. Now here I am, looking just at C. What's the equilibrium of C say? It says that for this to be an equilibrium, that force has to be 0. If it's 0 on one side, it has to be 0 on the other side. There's no applied load along the link. These are all two force members. So that's cool. 1 down, only 3 to go. You'll also know conveniently that they all pass through the same easy section. So we have to decide whether we work the left side or the right side. What's your choice? Left. I think the left is better here. So I'm going to just mark that by saying I'm going to go to the left. So looking at the left-hand side, do I need to find anything on the left-hand side to get started? I'm going to need the reaction at AY. It's a roller there. It may be hard for you guys to see. I should have made that image a little bigger. But it's a roller, so I just have one reaction, AY. So looking at a free body diagram of the whole structure, how can I find AY? There's a pin at E, so I'm going to some moments at E. So when I do that, this 500-pound force passes through E, and then I have 1, 2, 3 one-kip forces creating moment about E, all positive. So the first one would be 1 kip with a moment arm of 12 feet. The second one is 1 kip with a moment arm of 24 feet. And then the third one, 1 kip with a moment arm of 36 feet. That accounts for these 3. What about this 500? Well, that's also positive. And that'll be half a kip. And its moment arm is 48 feet. And then I have AY, which creates negative moment, also with a moment arm of 48 feet. So I should be able to solve for AY. I think it's going to be 2. (12 plus 24 plus 36 plus 24 divided by 48. Is that 2? Okay? So now I'm going to draw that free body so we can all see it. So on that free body, I'm going to put my reaction force, which is up, of 2 kips. I have the downward force here of 500 pounds, which is half a kip. At H, I have a 1 kip force down. And that's it for forces. Then I'm going to assume that I have a force in GH, a force in BC, and a force in BG. That looks very similar to the one we just did for example, right? Before we get too much farther, what's the slope of this line? Is that going to be convenient? It looks like it's 16 to 12. If you divide that by 4, it's a drop of 4 vertical for a run of 3, right? So again, conveniently for us, it's a 3, 4, 5 triangle. So there's our method of sections. We have 3 equations, 3 unknowns. Where would be a good place to sum moments? And again, look at the subscripts to help you make a choice. I got BC, BG, they share B. That'd be a great place. So let's start there. So I'm going to sum the moments about B and make sure it's in equilibrium. So looking at B, well, obviously BC and BG pass through B. They create no moment. So let's look at GH. Does that create positive or negative moment about B? It's positive. And what's the moment arm? It would be this height, which is 16 feet. I apologize for this drawing. I'm going to have to blow this up. This is almost, you can't hardly even see it, but that's 16. This 1 kip force applied at H passes through B, creates no moment. Then I have these 2 forces over here to deal with. Let's start with the 2 kip force acting up. Does that create positive or negative moment about B? Negative. And what's the moment arm? Be this distance, which is 12. And then the 1/2 kip force creates positive moment, also with the moment arm of 12. Now, if you wanted to, you could just add these 2 together and get a resultant force here if you wanted to save yourself a little time. So it'd really be 1.5 up. You get the same effect. So with that, we should be able to solve for the force in GH. I don't know what that is off the top of my head. That's 24, 18. What's 18 divided by 16? 1.125? 1 point, something like that? Does that come out? And that comes out to be negative, right? No, positive. Positive. So it's 1, what was it again? And that would be kips. So it looks like GH is positive, which means it's in tension. Does it make sense that the bottom chord element would be in tension? Yes. Is there another place where moment equation could be applied? Just to give you a hint, we got BG and GH. How about G? So let's sum moments about G. Just to help you visualize that, I'll bring the line of actions down and show you that they do pass through G. So summing about G, I'm going to have BC, creating moment, and all 3 of these forces. I'm going to have to stop now because I've kind of gone past my time. But I'll finish this up for you and post it online. And if you have any questions about it, we can talk about it Thursday. Okay? Sorry for the running a little long.